Hello everyone. In this video, we're going to work the last problem on the practice final. It's the combination problem. We have to translate this argument and then demonstrate its validity or invalidity. So I'll go ahead and get started on the translation. The first premise is that Hyde killed some innocent person. Another way of saying that is that some innocent person was killed by Hyde. So there's an X. X is an innocent person, PX, and Hyde killed X, KHX. The second premise is the claim that Jekyll is Hyde. That's the claim that Jekyll is identical with Hyde. The third claim is that Jekyll is a doctor, DJ, Jekyll is a doctor. And then the conclusion is that some doctor killed some innocent person. So there's an X such that X is a doctor. And there's a Y. There's a Y such that Y is an innocent person and X killed Y. Okay, so this is the argument. If we think that this argument, that's an X, by the way, doesn't look like one, but there it is. If we think that this argument is valid, then we're obligated to demonstrate its validity with a derivation. And if we think that this argument is invalid, then we are obligated to demonstrate its invalidity using an interpretation verified by full semantic trees. This argument looks valid to me, so I'm going to go ahead and set up for a derivation, and we'll go ahead and work out the proof. Okay, we've got this set up, and when we think about how we're going to proceed with this derivation, let's notice line 1 is an existential generalization, and just sort of assume that we're not going to be able to get around that. We have to work with it. And that's a big clue that we're going to have to use existential elimination as an overall strategy. So existential elimination takes two input types. One is the existential generalization we have up on line 1. Then the other is the subderivation that goes with existential elimination. So now I'm going to set that up. And we have to begin the subderivation with a neutral instance of the existential generalization. I'll introduce a name new to the proof, A, and then instantiate my existential up there on line 1 to the name A. The target sentence for my existential application of existential elimination is just my target sentence of the proof. That's what I want in my subderivation. That target is itself an existential generalization, of course. One way of getting it might be existential introduction on an instance. It doesn't have to be a neutral instance. I have a J up here on line 3 after the one place predicate D. So I don't know, maybe I can get it this way. D, J, ampersand, there's a Y, PY, ampersand K, J, Y. So I have J's in place of the X's in my existential generalization. Okay, so I have to have the same term there. And this next to the last line of the subderivation is itself a conjunction. One of its conjuncts is up there on line 3. So maybe I'll get this by conjunction introduction. I don't know, maybe I will. Conjunction introduction on line 3 and on this existential generalization, the right-hand conjunct. If I can get this right-hand conjunct on a line by itself, K, J, Y, then I can take line 3 and then this line and add them together with conjunction introduction. Then do existential introduction, replacing the j's with x's and adding the existential quantifier in the parentheses to get full scope. And then bump it to the next outer scope line by appeal to existential elimination. While we're at it, why not think about getting this existential generalization by existential introduction? On what? Well, it would be nice if I could get it on PA ampersand KJA, wouldn't it? Because I already have PA ampersand KHA. That's my auxiliary assumption on line 4. If I can get that H and turn it into a J, then I can do existential introduction, and I would end up replacing the A's with Y's and adding the existential quantifier. Then the question, of course, comes in, how do I get this? And there's a number of ways to get it, but I'm just going to take the fastest way to get it. That's going to be actually the next line of my proof. It comes from 2 and 4. Identity elimination. So what I've done is I've simply taken line 4 as is, and I've copied it down almost exactly. PA, ampersand, K. I changed the H to J, and then I ended on A again. So it's pretty much the same as line 4 with one change, changing H to J. I get to do that because line 2 says J is identical with H. So that's an application of identity elimination on lines 2 and 4 together. Then my existential there on line 6 is just existential introduction from line 5. Then line 7 comes from 3 and 6, conjunction introduction. Line 8, as planned, is an existential introduction on that line, line 7. And finally, the target sentence moved to the next outer scope line by an appeal to existential elimination on lines 1 and 4 through 8, the subderivation. And that's the combo problem from the practice final.